The field of machine intelligence has been on its way on aiding the world of information in processing huge amounts of data that we continually consume and produce. In the massive amounts of data being processed, it is key for computer to do prediction. Hence, machine learning continues to penetrate our world in being the tool in predicting outcomes and objects that we need. From all the algorithms of machine learning, the artificial neural networks have paved its way in handling the largeness of data consumption. Artificial neural networks mimic the brain with interconnected processing elements that solve a very specific problem. As trained, this is a self-learning computer program that adapts accordingly to the amount of training it receives. In comparison of that with our bodies, a nerve cell, also called neurons, have three particular parts that aid in understanding this mechanism. Dendrites act as the input wires, the axon acts as the output wires, and the neutron itself as a computational unit. Now we speak about how data come into play in ANN, classified into two types, which are training data and testing data. Training data are those fed into your system that act as a teacher of the system itself, with the system as its student. Testing data are those that are unknown and independent to your system, which will act as the consumer of your product, which is again your system. Now I will be showing you the typical graphical representation in understanding ANN. This is the typical diagram in understanding ANN. This is the input layer, the hidden layer, the output layer, and with these circles as the neurons. The links between them are called synapses. These synapses have their own weights and take value from their corresponding input nodes and multiply their weights with these inputs. The outputted values are now put into the following layers, and so on. These weights are crucial in the learning process of the system. These actually define how your system has strength to close in predictions. Now we talk about the neurons. The neurons are almost identical with one another, well, except for those at the input layers which doesn't have their own inputs. These components are the heart of the system that add values from their synapses, which will apply an activation function. With two properties, the neurons contain and be described by the following, which are the weight and bias. These allow which output is proper to be passed on to the next layer. To describe what happens within this network of nodes and links, we speak about the training process in neural networks. First, inputs are fed into a neuron. The neuron then assesses the current output value with its new input, which will then be compared to the right answer. The neuron properties will be adjusted accordingly from what the input has provided. Hence, we see the cost functions come into play in adjusting the error. With the same input, the new output is compared next. Finally, if the response of the new output is better than the current output from the first half of this process, the adjusted properties are retained. With this, training is essential in having more reliability for the system at the cost of having more datasets. Upon the explanation of the training process itself, it is important to take note of the process of scaling. The network scales down your data for the computer to be able to understand them. Also, activation functions come in many forms, but necessary for ANN is a logarithmic regression model called sigmoid function, which model nonlinear behaviors and responses. Seeing that hidden layers are very complex and unknown of their mechanisms, what we all know is that these are responsible of all the thinking. Hyperparameters is the term that are those seen inside these layers that are constantly updated at every training. These define the behavior of the network that does not allow adding more and more hidden layers as the training goes on. Hence, you are required to define the amount of hidden layers you'll be needing for the system. In the following video, we will be explaining the mathematics behind the artificial neural networks.